Okay, so now we're going to talk about information processing models of attention and memory. So the information processing approach assumes that we process information in a way that is similar to how a computer does, or analogous, I should say. For a computer, you might have some input devices like a mouse and a keyboard. There are input devices that, so you sort of input information using these devices, and that information flows to memory, and the central processing unit can also go into storage and recruit information from storage. But then the information will eventually go back into the central processing unit or the memory, and then present that information through some sort of output device, such as a monitor. Now, that might be a somewhat incorrect or at least a crude way of explaining how a computer works. I don't really know exactly how a computer works, but that's just just go with that. Just go with that. And so the idea is that in a similar way, there's a stimulus that goes into our system, right? We perceive it, we pay attention to it, and it undergoes some sort of process or collection of processes. And then there's some sort of decision-making process involved as well, which leads to some sort of response. And we can think of information processing as the storage and manipulation or transformation of information. Um, and so the major goal of cognitive psychology is to specify or identify the processes and structures that are involved in cognition, right? So how does attention work? What is attention? What is perception? What other thought processes are involved? What's the decision-making process look like? And again, the assumption here is that the processing of the mind resembles the processing of a computer, at least to some extent. Now, this doesn't mean that we're made of silicon, but the idea is that there is some resemblance or analogous resemblance according to this approach. And this comes from advances in information theory and a theory of computation. And the idea with information theory is that there's information in the world. There really is information. It's something that can be measured and it's quantifiable. And so, with these advances, the mind was increasingly being viewed in terms of a computer that processed information, and that information could be quantified. So, for example, in computer science, one may ask how much information can be reliably transferred or transmitted over an information channel. And what's an information channel? An information channel is simply some sort of medium that transmits information from a sender to a receiver. And because the mind was increasingly being viewed as a computer, cognitive psychologists started asking similar questions about the human mind. So, what is the channel capacity of a given channel? Now, I put this picture up here. This is Shannon's law, and it has to do with information theory. Claude Shannon, the person who came up with this idea, is a pioneer behind information theory. And I'm not really going to test you on Shannon's law or information theory, but I just wanted to put this up here for that reason. And as an aside, again, I'm not going to test you on this, but an interesting tidbit is that Anthropic's AI AI model, which is Claude, is named partly after Claude Shannon. So, as an aside, in any case, again, a channel in the context of a human mind would be sort of any type of perceptual system that can be used to process information. So, for example, you collect visual information with your eyes, auditory information with your ears, tactile information with your hand, but also the skin of your body, gustatory information via your taste buds, etc. Right? Um, yeah. And so, as an aside, I want to say there's way more than five senses, right? Not way more, but there are more than five senses. So if somebody says that they have five senses, you can tell them, no, there's at least 10, and I'm showing you eight here. In any case, all of these senses can be considered channels, information channels. And so, with this in mind, George Miller in 1956 discovered what he called the magic number. He was trying to figure out the capacity of the human mind. And he found that basically it's about 7 ± 2. And adopting concepts of information theory or from information theory, George Miller proposed an information processing bottleneck. So, because the information channels have some sort of capacity limitations, and those limitations uh, yield some sort of bottleneck in terms of how information flows. And he found that we could only remember 7 plus or 2 items. And an item is essentially could be anything. It could be a letter or a single digit number, or it could be a word as well. And he also he showed that you could remember how much you could remember more information by chunking the items into larger items. So chunking is essentially combining information in a way that makes it easier to process and remember it. And this can be done by grouping items into chunks or relabeling the stimuli in some way. And this is why, for example, a 7-digit phone number is separated into 3 chunks because it's easier to remember 3 chunks than if they're all just numbers that are shown to you in a string, right? And also, as mentioned in the book, natural language is the ultimate chunking tool because words are essentially chunks of letters that, when formed, are meaningful. And so, this is an example here on this slide of chunking, right? So, FBI, UNICEF, IRA, SAT, LCD, GRE. This is a 21 item string of digits. But of course, we could chunk these into meaningful chunks. And in doing so, we essentially compress 21 items into 6 items, right? So FBI is the Federal Bureau of Investigation. I don't know what UNICEF stands for, but it's a charity. It's a popular charity. IRA, that could be either, your retirement fund, or it could be the Irish Republican Army. SATs, I think, stands for Scholastic Aptitude Test. I don't know what LCD stands for, but it's a TV, right? GRE is, I think, Graduate Record Examinations, but that's essentially SATs for grad school. Okay, so we do have processing limitations, capacity limitations, but those can be overcome to some extent when you chunk, right? And so in the next video, we'll talk about information processing models of attention.